This is Algebra 1, 4.3, starts on page 216. This is a picture of Mount St. Helens, and the height of Mount St. Helens has changed. They've talked about what it was before it erupted and then how high it was after the eruption. So you'll have a problem later that will address that. All linear equations in x and y, where you have the x and y, can be written in the form ax plus b equals c. When a is 0, when a equals 0, the equation reduces to by equals c because it was 0, a was 0, and the graph of the equation is a horizontal line. When b equals 0, the equation reduces to ax equals c, and the graph of the equation is a vertical line. So I'll walk you through this. Some spelling words that some vocabulary words that are key to doing this lesson is it's horizontal line, vertical line, the coordinate plane, x-coordinate, y-coordinate, constant function, domain, and range. So we'll be using those words throughout this lesson. So we were going to do directions that said graph the equation y equals 2. We can see from our equation that we do not have x as a value, so there's no x, so we just cross that out. And the y-coordinate is always going to be 2, so that is going to put that right there. That's where the 2 is. It's always going to be, right there. So regardless of what x is. So for instance, if we had some points that were, let me get a different color here. Let's say we had -3, 2, or 0, 2, or 3 and 2. It's a 2, it's a 2, it's a 2. Y always equals 2. So if y equals 2, in this one right here, -3, we're going to have -3 would be right there. My stylus is having difficulties getting it in an exact spot here. So I'm just going to line it up with where this dot is, but it should be farther down. It won't make a dot. I don't know what's going on here. Let me try to erase this and try it with a different stylus. Okay, well, that's the best I can do. And then down here, 0, 2. I got 0, 2. That one's this one right here. And then I have 3, 2, which should be over here. And so now you can see that we have a straight line that's not really where it should be because I can't get my stylus there, but it's supposed to be on this, the 2 would be right here, and so the line would be connecting all the way across. It's hard to see with my picture here. And so the graph of the equation y equals 2 is a horizontal line 2 units above the x-axis. And so here is the x-axis, and we're going to be 2 units above that. It's a straight line going across. The y stays at 2 all the way. It's just the x values that change. So now we're going to look at a graph that y equals -3. And so we know that y is going to be -3 the whole way through. So that means that this is our -3 there. And we would have, we can plot out our points. We could do, well, you could do anything that, so the y is going to be negative 3, so you could have x be negative 2 if you wanted. So that means that it would be right there. I made my stylus size of writing smaller, now I can barely see it. And or we could have over here, we could have 3 and negative 3. So that would be over here. But any which way, we're going to end up with a horizontal line. Horizontal line going across, representing that 3. So now we say y equals 4, it means that it's going to be a horizontal line going across the 4. If we had y equals 1/2, now that one's kind of interesting, but it would just be at the, oh sorry, put it on the wrong, didn't go there. It goes right about right there at the halfway mark. If my pen will do it, it should be halfway. I made it too high, but where it should be at the halfway mark. So that's gives you working with the y's. So let's say we have x equals negative 3. So we could have some coordinates. We could have negative 3, negative 2. We could have negative 3, 0. We could have negative 3, 3. The x is always going to be the negative 3. Now the y's are changing. So we know that, so negative 3x and negative 2 is y is going to be over here. Negative 3, 0 will be right there, and negative 3, 3 would be right there, and our line is right there. And it is a vertical line. Okay. So the x is a vertical line, and the y was when it was 0, was a horizontal line. And we would explain this by saying the graph of the equation x equals negative 3 is a vertical line 3 units to the left of the y-axis. Now we can do the reverse. Let's say I have drawn this blue line, which I did, on my graph. You know it's going up and down, so we're talking about a x values, and we're talking it's horizontal. And how would you now write an equation of the line? Well, what we know here is that x equals negative 2. And so our equation of the line is x equals negative 2. And we've graphed a horizontal line. Now, let's say, let me give you a different one. On this one right here, I had marked that it was horizontal, and it isn't. It's a vertical. The x is a vertical line, showing that x equals negative 2, and so the equation of the line is x equals negative 2. Let's say you saw this line and it wanted you to write the equation. We can see that y is on 4 there, and so we would say y equals 4, and that would be our equation. The equation of the line is y equals 4, and this is a horizontal line. Oh, on the other one, I think I wrote horizontal, I meant vertical line. A constant function is a linear function of the form y equals b, where b is a constant, is also written as fx equals b, and the graph of a constant function is a horizontal line. The other thing about a constant function is the range is a single number b, which I'll explain in a minute. So this is a graph of the height of Mount St. Helens from 1860 to May 1980. Now, I don't have the right, well, let me see if I can find a different graph here. So I'm going to do a graph of Mount St. Helens, and I had one graph that had all 4 coordinates, but we just need the 1 coordinate, so I switched it up. I'm not sure what stayed on the tape or not. But if you look down here at the bottom, I have the years since 1960, and I did it in, I have 20, 40, 60, 80, 110. I could have written in, 10, 30, 50, but I didn't. Over here I have, you can see this little kind of a zigzag thing here. That shows that I'm skipping numbers I'm not going to write them all in. Sometimes when you're using a textbook or you're out of space, you can do that, because really all I need is the 9,000 and the 10,000. So for this case, I'm going to do that. But I have to show that I sort of skipped to get there. And if you had the chart, you can see that, let me mark it, that the graph's going to be, let's see, somewhere about in there. I think that's probably a little high for what the number I wanted. But between 1860, which is what would start here, that's my 0 point, and 1980, so it's 1860 to 1980, the height was 9,700 feet. So the equation for the height during this time is that h equals 9,000 feet. The domain is all the values of t between 0 and 160. So down here we're talking about the t. Okay. So the range here is a single number because it stayed all one thing up here. It's a single number. Just to clarify, the domain of all values of t, of the number of years, is on the x line, and the range is only one number because the line stayed at the same place all the way through. In 1980, Mount St. Helens erupted. The blast took away the peak. The eruption took away most of the peak. The height of Mount St. Helens after the 1980 eruption was 8,364 feet. So it's obviously less. So that would be, we could say that that was, maybe, we'll put it right about there. So now, how would you write an equation that represents the height of Mount St. Helens after 1980? What would be the domain of the function, and what is the range? So the height is going to be 8,364. The domain will be all the values from 1980 to present. So if we did a whole different number line, and now we wrote in here 1980, we ended with 2017 or whatever. That isn't in the proper increments, but that would be the domain. That would be the values of t down there. So in summary, the equations of horizontal and vertical lines. The equation is we have x equals a and y equals b. And the y equals b represents a horizontal line, and x equals a is a vertical line. Okay, so this is Algebra 1, the end of 4.3. The exercises to do are on pages 219 to 221. Make sure you write the lesson number and the page number on your assignment sheet, as well as what the assigned problems are. You need to do problems 16, 17, 20, 21, 26, 27, 31, 33, 35, 36, 38 through 52 evens. The 38 through 52 are the evens. And then quiz 1. And it is due tomorrow. Or you can take, if you don't get it done today, take it home. It's due at the beginning of class tomorrow.